Hi, well the main reason we have the alcohol rocket is to really emphasize the difference between the solids, liquids and gases. Okay, so the major difference is the textbooks have the solids and liquids here, and the only difference between solids is there's this vibration going on with the solid, and with the liquids you can have this turning movement. But as you heat up solids and liquids, what you see is that the difference in the volume is really quite minor and really not that exciting. So if you heat up metal, it might go red, but no noticeable difference in the volume. What your textbooks will try and do, and this is probably being generous on the textbooks, is they'll have a bit more of a distance. This is far more extreme. It just shows you how wrong the textbooks are. It's about 1,000 times difference. I don't know what you're going to look up. If you look it up, you'll see some information about just how different the volume is. For this here, I don't think I'm really giving you a 1,000 difference. If I was going to take this by 1,000, it would look a little bit like this. So what I've got here is a solid, and I've just done 2. And if I move along, and that expands out to a gas, and I make it to 1,000, that's about 1,000 volume difference. And there's one of them, and I've randomly placed one on the other side, which is not that random. Alright, and so you can see that that is why textbooks can't handle sort of an accurate difference between the solids, liquids and gases. The gases are just too crazy. You can't have a page that big and then in your textbook this massive huge page that hangs out and fills the whole house, or at least the room. And so that's the main concept, is that the gases are massively different. There's huge spaces so that they can easily compress and expand, and as you saw that the huge amount of expansion that occurred with the gas inside the bottle. Now that also demonstrates when you heat it that those the particles are free to expand rapidly. This doesn't happen with the solids, liquids and gases because they are under, if I can just get out of here, because they're so close together, they actually stick to each other. So if I can just find out where my marker is. So there's positive protons in the nucleus and there's electrons around the outside, and these are positive electrostatic forces and these are positive and negative forces attracting each other. We call them intermolecular forces. It's basically stickiness. And these electrons are sticking to this one here, so this atom here is sticking to this one. Because they're so close together, this interaction actually occurs with solids and liquids, and that's why they can't really pull away from each other very much, even though you heat them up with enough kinetic energy to roll over each other or vibrate more, depending if it's just being heated up or changing state. Whereas once you're in a gas, all of that kinetic energy is just free to make them just zip out of control. There's no stickiness, there's no positive negative interaction between the two. So that's the concept to learn about the real difference between solids and liquids and gases. Next is the teacher information. So I'm just going to go through the video, the proper video, which is sort of the full length version. And what you'll see first of all is I've used an aluminium pole, which is completely pure aluminium at the end. I think it's actually meant to be, it's from Bunnings, it's meant to be just for painting, putting the rollers on. 100% pure alcohol. You can see here, maybe here, yeah, I go and wash my hands because I've got alcohol on me then. I'll make sure I don't get alcohol when I get myself off. I've put a little splint, sticky taped it on, and then sticky taped some paper on, and then doused that in alcohol to give me a little bit of a flamethrower because that's a bit of an issue. You just shake it up a lot. When I released it, you usually get this pressure this coming out of your hands, and so that's a good sign it's going to work. It's just a bit of a dodgy experiment because it's all dependent a little bit on pressure. I also don't like the fact that the plastic is a lot thinner. I'm used to using quite thick plastic, but that was the most spherical bottle I could get, and it still spun a little because it wasn't really on the thing nice and straight. So what are the other things you need to be aware of? So I'm a bit worried about the thinness of the plastic. I'll no doubt have butane bottles here. I've actually had bottles blow up using the super thin plastic. Not as thin as that, but I'll get to one of those in one of these videos. So I'll have 52, perhaps 53 of my favorite videos on here. So it's quite long. The sound is a little bit loud, but not enough for earplugs. There will be some experience, and the butane bottles definitely you want to have earplugs in. And the size of the, just show you the size. This size here, which I just heated up the end of the retort stand, so I got that piece of metal, and then I burnt a hole in there. I'm sure most people can do a better job than me. That's about the size that it should be, and you can see there that's the bottle I got. I think it cost about $10, so you can go to that company there. There's all the details there. It's 12 litres. So that's about it. Definitely not something you'd let the students do. I've just got some details here also, if you're curious. Just looking up the density and stuff, and doing some gas stoichiometry, comparing liquid density to gas density. 24 was a bit of a guess, so there's a lot of assumptions. 22.1, I'm not sure if that's STP or not. And so I just did some basic calculations just to verify, yeah, it is about 1,000 on the internet, so it was 1,100 or something. And so it is that dramatic. Another thing is that this experiment has the biggest issues in winter. So in winter, when it's like 10 degrees or less, it's like 3 times less than summer. So 25, the vapor pressure being 25 compared to 75. I found also if you just heat the alcohol up in a separate bottle, like put hot water around it, that helps. But it cools down quite rapidly when you put it into the bottle, but it does help, so maybe gets it up to about there, and you can get it to work in the winter. It's a little bit difficult, so it's a little bit variable on vapor pressure as well. So that being said, just have the students stand well back. In that particular experiment was just me practicing it, so I haven't had students in it. I might have them sort of in the room still, peering out the windows or something. I'm not quite sure what to do with that one yet. Alright, I hope that was helpful. These are mainly for teachers, so please put a like and subscribe, and that'll encourage me to do the second one. And maybe I'll get to 53 of these. Definitely some more reliable ones. This is probably the dodgiest one, and the one I haven't done for at least a year because I haven't been able to get it to work since I've come back to Australia, where I've done a lot of other just as cool ones that are probably a lot safer and definitely reliable. So this is the most unreliable one, I would say, although hydrogen's got a variable flash point, so that explosion can surprise you sometimes as well. Alright, thank you.